Okay, hi everybody. I saw some familiar faces already from last night. I also organized an event called Unstructured Data that was at GitHub. And so I'm also going to speak tonight. My coworker Frank spoke, and I will try to fill his big shoes speaking about multimodal RAG. So this is me. My name is Christy Bergman. I'm a developer advocate at Zilliz. Zilliz is the company of maintainers behind an open source vector database called Milvus. Yeah, so this is me. Feel free to follow me or connect with me. Sorry if you already heard this little spiel. I'll keep it down to 5 minutes just about who we are. Vector databases, you can high level think about them as open source or closed source. And we have a foot on both sides. So our open source Milvus was donated to the Linux Foundation. So it has a very generous Apache 2 license. It means you can build on top of it and even charge other people money for whatever you build on top of our open source product. We also have the managed Milvus, Zilliz Cloud, which runs on AWS, GCP, or Azure. And then if you code in Python, for example, leaving off the index definition, so it defaults to a system auto index. On open source, it'll default to HNSW, and on the closed source, it'll default to our proprietary index, which is faster. Okay, you all probably know high level 3 pillars of AI, which is the compute, the CPUs, the GPUs, the TPUs, the LPUs now with Grok, all those awesome models out there from OpenAI, Meta's Llama, Google's Gemini, for example. And then don't forget the unstructured data. Unstructured data is the majority of data out there. Supposedly most of the data out there, except for spreadsheets, is unstructured. So text and images, videos, sound bites. So there's a lot of opportunity, we think, here in this space. We're going to have our first Unstructured Data Summit at the end of the year. And you might want to take a picture of this. I'm going to raffle off one Zilliz hoodie at the end of my talk. So a little hack is, if in case you've already starred our Milvus GitHub, go ahead and unstar it. I know that feels weird, but then start again, and then you'll show up on the top of the list, and I'll be able to enter you in the raffle. Okay, I'm going to talk really briefly about RAG, and then I'm going to talk about multimodal embeddings, and then give a demo. So high level, I was up until just a few weeks ago, I was able to go into Gemini and I would ask, list 3 politicians born in New York, and one of the politicians listed would be Hillary Clinton. But then you go to Wikipedia and you see she's born in Chicago. So as of that's a hallucination. But as of this week, I noticed that the same question has been updated, and now they'll say they don't want to answer anything having to do with elections or political figures. So anyways, yeah, so that's a thing, hallucinations in RAG. And why do models hallucinate? They are trained on sequences of tokens. So for example, if you're trying to predict the chicken walked across, probably the road is probably the next token, but there can be weird stuff that creeps in there because of the training data. It's trained on all kinds of things. Imagine like Reddit, for example. Where do the vectors come from? We're going to talk about vectors a lot. The vectors are the lingua franca of AI, and they come from deep learning neural networks, not the very last layer, which is often a softmax, mapping the outputs to 9 classes for numbers, for example. But the next to last layer, which is what that model has learned from all of its inputs, training data, it's mapped, learned to become a big f of x, and take all those input x's and output them f of x's or y's or vectors. And so that last layer represents all the trained weights or the output vectors that this big fancy function would output. And these vectors we store in Milvus and we can search them. And I'll give a demo soon. So here's the picture, a high level view of RAG, which our previous speaker also mentioned they're using. So you take your own data, you embed it using an embedding model. you store it into a vector database, for example, for fast retrieval. At this point, then you would deploy this thing into maybe a RAG pipeline or a chatbot is the most common thing. A user comes along, they ask a question. That question needs to be embedded using the same embedding model into a vector. And then the calculation of approximate nearest neighbors is a super fast computation of cosine similarity, for example, distance of those two vectors between your question vector and all of the vectors in your knowledge base. What comes back, you stuff it into the prompt as context, and the question plus context as prompt goes into the generative LLM model, which is a different model, and hopefully you get back a more reliable answer. Which brings us to multimodal. So my colleague last night did a really great history of embedding models. I'm just going to borrow one of his slides. In the beginning, image vectors were handcrafted, and this is a picture from 1970 of a handcrafted image vectors. And then move a little bit a decade later, they're still handcrafted in the 1980s. And then around circa 2000s, CNNs became very popular as a way of encoding images. But 2017, the paper "Attention is all you need" changed everything. Today's multimodal embedding models are all pretty much based on transformers. So the original paper had two parts to the transformer, the encoder and the decoder. And what's happened now is, most researchers now just use the encoder, and that's the embedding model. Or they use just the decoder, which is now the GPTs of the world, or we shortcut call them LLMs. The paper came out in 2017. 2019, the sentence embedders came out. Nils Reimers, who's currently with Cohere, for example, created this sentence transformer, which is on Hugging Face, which is still the most common text embedding model used. Basically, you take and train on sequences of sentences of tokens, and then you combine the outputs into that next and last layer using cosine similarity pooling. Moving from text to vision, though, now the most common architecture is this thing called a vision transformer, where you take your input, for example, an image, and you take little patches of that image, and you have attention on the different patches, and then pass that to another transformer. This is called a vision transformer model. And this is all like 2020, 2021 technology. So there's a lot of room to grow here in these embedding models. So with the vision transformers, you can do things like input an image of French fries, and you'll search your database of food and find more French fries. So pretty awesome. Just to point out that these embedding models are the workhorses of LLMs. If you go to Hugging Face and look at the number of downloads in the last month, for example, if you look at this BGE large, it was downloaded 1.4 million times. But then you go to even a very popular Llama 2, for example, there's Llama 3, 70B Instruct, it's 500,000 times it's downloaded. So these embedding models are just, I think they don't get as much credit as they deserve. They really need, this is where a lot of innovation is going to happen, I believe, and very soon. So multimodal embedding models, what they're doing is they're taking these embeddings of text and images, and they're putting them in the same vector space. And what that does is it lets you do that very fast cosine distance calculation real time in your chat app. So for example, you might have images of lions, sound bites of lions, videos, and text with the word lions. And they're all in the same embedding space. So you might search with text and come back with an image, or vice versa. Just a high-level view of these multimodal models. They're generally classified as late, mid, and early fusion models. And late means that you've got two separate embedding models, one for the text and one for your images. and they're trained using contrastive learning, and then after each individual model has been trained, there's called a late fusion step, where you merge the embeddings from each of those separate models into one embedding space. Mid-fusion, oh yeah, so OpenAI Clip is still the most commonly used model there, and it's a late fusion model from 2021. I'm going to be demoing this one called UForm pretty soon. Mid-fusion, same thing. You've got separate models for each modality, but then you train another separate model, multimodal model, in between. So this is called a mid-fusion. And then a holy grail is this thing called early fusion, where you are actually training them all in the beginning at the same time, all modalities. And we only have one example of that, Meta Chameleon, which until yesterday, when my coworker gave a demo, it was only available as downloaded weights. They had to run on GPU, but yesterday, Hugging Face, it just got posted on Hugging Face, which means it runs on CPU. So look for that. Upcoming demos will be able to do that. Yeah, and just to stir your imagination, there, besides text and images, there's other things like molecular fingerprints can be represented as vectors. Sounds can be represented as vectors. Graphs, where each node in the graph is represented, all the nodes connected to it are vectors, and even time series. RAG. Okay, so yeah, this is about the end. So bringing it back to RAG, this is what these multimodal embeddings let you do is take, instead of just taking text, now you can input all these different modalities, use the RAG pattern using a multimodal embedding model now to put these different vectors that represent different modalities in your database, and then ask questions about it. So I think it's time for a demo. I'm going to be using, our previous speakers spoke about small models. I am also very bullish about these small models. I love them because I have a poor person's laptop. I only have 16 gigabytes of RAM on my M2. So I need an embedding model that I can download locally and run. So that's what this is. It's using Onyx instead of PyTorch, which the creator told me PyTorch is just takes too much memory. So he's made it very small and portable. And I'll actually switch here. This is make this bigger. Yeah, they're making it hard on me because I can't move this thing out of the way. Oh, there we go. There we go. Yeah, so this is UForm. It's built on Clip with the vision transformer architecture. It's what they want to show off down here is when you see these @1s and @5s, it means searching with a top K equals 1 or a top K equals 5. And they're pointing out that their tiny little model at top K5 is beating even OpenClip with a whole bunch of different languages, Arabic, for example, even Hebrew. So yeah, so that's what I'm going to use. Now let me go. Is that, maybe make that a little bigger. Okay. Okay, so what I'm doing is I'm taking, oops, what I do. Oops, what did I do? Oops, I lost my sound. Oh, dead battery. Oh. Oh, thanks. All right, battery just ran out. So yeah, I am going to download some images. Here's there's a website here that same creator has all put into Hugging Face datasets. I need to download a little mapping file of what is the text that goes with each image. I'm going to create a Milvus collection. So the thing to notice here is that I'm going to have two vectors in this case. I'm going to have this one, which is a text vector, and then I'm going to have a separate one, which is an image vector. And these vectors are 256 dimensions, which in the world of embedding models is pretty small. The open clip, I believe, is 1024 for comparison. And then the other thing to note when you're doing this, you need to specify an index for each one of these vectors. So in this case, I'm going to be using the auto index, and I'm going to use cosine distance as my metric. So you do need a vector database that supports hybrid search. Just little plug there. And not all vector databases do. All right, so I'm going to use just going to download this from Hugging Face, the multilingual small embedding model. And then because my laptop is so small, I'm restricted to a very small batch size. I can only do 10 images at a time. And I'm only going to do 100 here live in my demo. So I'm going to embed 100 images 10 at a time using their model. And I'm just doing this on my laptop. And so you should see there's about 10 of these that ran, and my average embedding time was 4 seconds. And then I insert all those 100 vector and text embeddings in my database. That takes 0.03, so much less than 1 second. So this is another interesting thing to know if you are an implementer, that it's the embedding that takes the most amount of time in this kind of workflow. I might talk about that a little bit later. So I've got all the stuff in my database. Now I can do the fun things. So I can maybe ask some questions. I've got a couple questions lined up here. Instead of asking brown leaves, I'm going to translate that to French and try out the multilingual capability. And then I've also got an image of a cat. So here I'm just doing just doing pure text search. So I'm going to ask my question about brown leaves in French and ask for images back. And so you can see, yeah, even with only 100 images to choose from, it found some pretty good images. I am restricted because I didn't load that many images here. And now I can do the opposite. I can do reverse image search, and not totally opposite. I'm doing image search first with text, and now I'm doing image search with an image. So image search with image with my cat. Okay, I found another cat at least that looks pretty similar. I can also do both image and text at the same time. So let's say I have this question, Rocky Mountains at golden hour, and I could use, I think the last language I have there is Arabic. So I could translate that to Arabic and say, give me that either text or this image. And so what's going to happen here is both text and image are going to be searched. You're going to have 2 top K lists, and then you need to rerank those top K into a single result. So that's what happens here with the top K4. And most of the images look like mountains at sunset, except that last image is a miss. And I think that's just because I don't have enough good images here. And you can also see, yeah, it's not finding a great result there. All right, so now I'm going to this is not meant to be a GPT-4o demo, but just to close the whole multimodal RAG loop here, I'm going to go ahead and ask GPT-4 to write me a blog in Hindi and output HTML. So I'll go ahead and I'll give it my images, and yeah, I got an output. So this is showing that the reason why we are interested in this multimodal embedding is because GPT-4 and these things exist. These are multimodal LLMs. So you want to be able to give these LLMs images, for example. You don't want to just have to give them text. now I should be able to go back. Okay, and I got a blog checking with my cat, so that worked. Yes, GPT-4 can generate using input images and instructions, which we all knew it could anyways, but this was just to close the loop of what a multimodal RAG does. Now, in my demo, you saw I only was able to embed 100 images because I'm just doing this live on my laptop. That embedding step is what takes the longest. So I did a separate thing where I embedded 3,000 images, and I'm going to go ahead and connect to that. Oh, shoot. Okay. Oh, is it a network problem? Oh, darn it. It is connected? Yes. Darn it. Okay, I'm gonna have to do this again from scratch, so it's not gonna be as fast. Oh, darn it. This is gonna be my punchline. This is gonna be so fast, so cool. Okay, I guess I have to do it from scratch. It's just hard to. Oh, shoot. Oh, shoot. Darn it. All right. There's the trouble with a live demo. Yeah, I think so. Yes.
Thank you for staying patient, guys. It's live demo, so you probably understand the difficulties there. Think about that from him.
Yeah, while I'm doing this, oh shoot, I can't do anything else. Maybe we should have your next speaker, and then I can come back and do a little ta-da.
That works too.
Okay. All right, I'll do my little ta-da. I'll only take like a minute to do that. And then I can do the raffle at the end. Okay.
That's because, you know, the demo was.
Sorry. Um,
Unmute. Yeah, I'm recording. Let's go into that side.
Now it should work.
Close this. That's a browser.
It's going on.
It's not presenting there.
No, it's not. Let's try the other cable.
No, that's not the USB-C. This is the one. Yeah.
Or can you directly plug in HDMI?
Wait. Oh, it was working.
It was. Okay, sorry.
Okay.
We are slowly getting there. Thank you for your patience.
Or the demo gods are getting angrier.
Yes. I do not know what's happening here. We tried this.
What about, is it this cable? Maybe this one?
Oh, yes. Now I'm gonna picture.
It seems to show something.
Please connect. Oh, working.
It's
Okay, there we go.
working. Okay. How do I go to it? Let me. Okay, it's recording now. It's recording the screen. Does it need to record?
Yeah, you don't have to do anything about the recording.
I don't need to do it.
Yeah. You just start presenting. Can you share your screen? Because
Yes.
maybe the co-host is.
All right, slideshow. And is this working? Can you hear me? Yep, cool. Yep, all right, cool. So, hi everyone, I'm Iman. I'm from Firebase. I lead some of the serverless teams, the access teams, and I was on the founding team for Genkit. Just before I go into the talk, all expressed in this meeting is my own opinions, not my employer's. So
I'm sorry to interrupt. Are you sharing your screen on Zoom?
I don't know.
You might want to because it's not recording.
Okay. You said I don't need to do
You need
anything.
to just share the screen.
Oh, okay. Share screen. This is the screen I should share. Cool. All right.
Okay, perfect.
Good. Yeah. Now you can see my bulky figure. All right, good. So I'm here to talk to you about Genkit and tell you the story. I want to take a step back, go a trip down the memory lane before that, talk about how software development was and how it evolved when generative AI came to existence, and then use that as a precursor to go into the Genkit story and why we developed Genkit at Firebase. So the first thing is AI app stack. And what I mean by AI app stack is actually using AI to serve features to your customers in your apps, not like using Copilot or code gen models to like help you code, but actually serving models like how Cooper presented, like that was like an example of an app using AI. So back in the day, software development was, a process. We had software architectures. We based on the customer requirements, based on, our needs, the load, the constraints, the SLIs, the SLOs, and all the requirements here and there, the platform available, we would devise an architecture and we would develop software. And this was like great. And it wasn't just about like, just a 2-tier or 3-tier. Eventually it evolved into multi-tier. Then we had like multi-databases, multi-servers. Then cloud came and we had elasticity, microservices, serverless after that. And, all of these still exist. And all of these are like great architectures. You might use them in your app. You might use a combination of them. It's up to the developer to decide like which of these fit their needs. And then we had the generative AI wave. We had these great powerful models that came with a lot of like power. They would generate stuff. They could go over your documents. They could extract knowledge. They could extract data. They could generate poems, stories. They could analyze your legal documents. They could analyze your medical images. All those powers came available. And that was when we developers felt that, okay, it's time to put this power to use. Like maybe we can serve features to our customers. Maybe we can like add additional user-facing features. I remember back in the early days, we had an internal presentation at Google. We were getting like introduced to generative AI, and the PM, it was from Gemini team. He gave a definition of generative AI, which stuck in my mind. And it was basically generative AI is making AI accessible and easier for everyone, not just modeling scientists and not just ML experts. So instead of training a model to do something for you, you would give it a prompt and it will respond back with something that would be useful for you. And that was very like triggering for me, that this is the whole concept and this is how we should think about generative AI. So it was like this, and we were thinking about using generative AI in our apps, but then something came along and we started developing AI frameworks. And these AI frameworks came up with new concepts and new paradigms and new abstractions and different things that we had to learn to use these models. And it became kind of overloaded over time, and it became a bit more difficult, and it was challenging to understand. And these also came with a lot of like pre-built utilities and abstractions and plugins trying to simplify developers' lives. So you want to use that database, here's a pre-built component for you. You want to use that file storage mechanism, here's a component for you. You want to do this type of authentication, here's another component. So everything was being pre-built, and the focus was on the AI part, where you work on the model, work on the prompts, you're back and forth with the model, tinkering with the prompts. But for software developers, where we were the people who cared about databases, we cared about our connection pool. How do we run this query? How can I make it more efficient? You know, this index, maybe join it this way or that way, or how do I like define my scaling mechanism and things like that. All of those things were being abstracted away, and we were left with the AI part. And eventually, I guess you've probably seen it. This is probably the most famous graph out there about like the emerging LLM app stack, where it had a very bold orchestration piece with AI front and center, and the rest of the components of your app stack was built around it. This is from Anderson Horowitz's blogs. And it was very famous. And basically, everything here was built around the AI orchestration part. It felt that generative AI by itself was a revolution, and I really believe it is. But we were trying to extend that revolution to software application architecture and the app stack, and trying to redefine that around generative AI. And we put everything here. It was kind of the orchestration piece is now becoming the new middleware. And this was making lives more complicated. You don't believe like how many hours we spent internally debating that this architecture is not how an application should be built. And this is the wrong architecture. So these were like all these like big orchestration platforms, and they were so opinionated and so bloated with all these different components. They couldn't run on traditional platforms, and we had to build like tailor-made platforms to run them, to monitor them, to observe them, and all that stuff. So what happened? This middleware got so bulky that it became too difficult to understand, too difficult for developers, and by developers I mean software developers like me, to understand, to grasp the mental model, try to run production apps, try to monitor it, observe it, debug it. All those things became challenging. And we also saw signals across the web that, getting these things into production is challenging. And a lot of use cases around how they rewrote it in basic code, and it was actually much, much more smoother. So we felt, how did we get here? Like basically we wanted to make AI simple, but by introducing all these concepts, we actually made it more difficult. We brought more definitions and more jargon and more abstractions to the developer, which made it more difficult for the developer to grasp all these and more difficult for them to build applications. So as we were looking into this, we thought, like, is it really the need to make it so bulky and so heavy and a kitchen sink for everything? And do we have another alternative way to develop frameworks for developers that can actually simplify their lives? And that's how we landed on Genkit. Now I'm going to go into Genkit and tell you how Firebase started the story. But before that, a quick introduction to Firebase. How many of you know Firebase? Okay, so and have you worked with Firebase? Cool, good. So Firebase is all about app developers. It's about web developers, mobile developers, backend, front end. Like all of those developers are what we target. And we have 4 million active monthly developers. If it's not the biggest, it's one of the biggest development platforms out there. And it's built on Google Cloud. So it started with a database. It's now extended to more than 20 different products, from serverless, from databases, from real-time messaging, from authentication, access, hosting, and on the mobile side, crash reporting, crash monitoring, feature flags, testing, messaging, notifications, all that kind of stuff, and A/B testing. So these are all the utilities that Firebase develops. And basically, as I said, we target app developers, and not only the product team, but and the engineering teams, but even our UX teams, our research teams, spend hundreds of hours talking to developers who build these apps, who are working with databases and web servers and the traditional stuff. And we try to understand their mental model, how they think about stuff, how they go from code all the way to production. What are the challenges? Where are the frictions? And we call this the developer experience, and we model these developer journeys. So I'm telling you these because we really care about that part. And that's why when we approached AI and we were trying to generate an AI strategy for Firebase, we felt the friction with the tools out there, and we felt they're not the right tools for the target persona that we have. So we sat down together. We said, okay, let's redesign everything from scratch. Let's see what we can do. And we set some guiding principles for ourselves as we go through the process of designing Genkit. So first, we said we have to start with the app developer. That's our primary persona. We have to distinguish it from the researcher, from the modeling scientist, and from the ML researcher, who are a different type of developer. We have to separate these two, and we have to characterize it well. So we defined our target persona as application developers, are people who develop web apps or develop cloud apps or mobile apps. Then we said we will embrace the existing tools and platforms and products and processes as much as we can. So there's less of a learning curve and less of a jump for the developer to onboard to generative AI. So if they're using cloud, let's embrace cloud. If they're using databases, let's embrace databases. If they're coding in an IDE, if they're running in a CI/CD, if they're running tests in a specific framework, let's embrace all those, and let's not bring new concepts to the developer to make it much, much easier for them to onboard. And third, we said embrace code as a primary artifact. So code is where your work should live. Code is the source of truth. Code is where everything lives. And we want to embrace that, and we don't want to create new types of artifacts in different areas. Everything should be code. And iterative development was key. We believe that iterative development is a key to building successful production-ready generative AI apps. And that means taking small steps, launching, deploying to production, getting feedback, then the next step, and the next step, and so on. And with iterative development comes, all the tools around observability, evaluation, all that kind of stuff should be supported and be supported in production. And fifth, be production ready from day one. That means there should be a very clear path for the developer to productionize the code. It shouldn't be something that we develop separately, that we research separately in a different environment, and then go to the development environment and try to rebuild everything from scratch. It should actually be built in a way that can go into production. This actually helps us to be more iterative, because the more it's easy to take something to production, the more it's easy to iterate on and get quick feedback and take the next step. And so we said, okay, so with all these in mind, how can we design Genkit? What is the basic building block? What is the foundation that we need to create? What is the abstraction we need to create? And we thought maybe we don't need to create an abstraction. Maybe there's no new thing that we need to create. What if we use an API? The API is how we call into a model and how we get a response back. What if we just use that? That should be the key thing. And then we said, okay, the model call should be as simple as a function call. You should be able to use a function call anywhere in your code, anywhere in your stack. You can do it wherever you want, in your CI/CD, in your backend, in your front end, wherever you want. When you make a model call as simple as a function call, that should be easy enough. And we thought, we were thinking, okay, a model call is as simple as a payment API call, an authentication API call, a storage API call. But there were fundamental differences. We know generative AI calls are non-deterministic. So one, they cost a lot. They're not as cheap. The cost might be based on the number of tokens, based on whatever the model is, or they might be free. The performance varies a lot, even to the same model. The same prompt might vary from time to time, but even different prompts, they also vary a lot. There's a lot of randomness inserted into models, so you cannot predict what they respond. Even the same prompt gives you different responses. Safety is a serious issue. Not only they hallucinate, they sometimes produce garbage. They also produce some nasty stuff. So if you're going to put something into production, your business might be at risk. So this is also critical. And validation is hard. Developers care about validation. They care about testing. They care about making sure it's running perfectly in their runtime. But validating output of generative AI is difficult. So with these fundamentals, we developed Genkit over the past several months. We launched it at Google I/O, the first versions, and these are the key things that we have in Genkit. The first thing is multi-model development. We believe that not one model is sufficient for the developers, but the variety of models and each of them with their characteristics and their performance and their, better response in one area or the other, the developer would use multiple of them in their development. And we developed a modeling abstraction that can support all the different models out there. We support many of the mainstream models, and there's a plugin system to also support more of them. But using those models is easy for the developer. Then, prompts are code in Genkit. So you define your prompts either in code, and it's just version controlled with you. It gets PR'd, peer reviewed. It gets committed. It gets launched with your code to staging, to production, monitored, version tagged. Everything is there because it's just code. And also, we thought that in larger teams and with different roles and more expertise, there are more complex models, so we introduced a new format called .prompt, which has the prompt parameters, which has the structure to calling the prompt, and it has a prompt itself. This lives by your code, but in a separate file. So between teams that have different types of expertise, they can work together and they can iterate on the same thing. They can execute these together. And then we thought about structure and type safety. So a lot of the talk is about chatbots and RAG, but basically we thought, what if we could use generative AI for more use cases in backend, like extracting user information from an email, or like moderation of content, or extracting data from a text, things like that, and using them in your code logic, using them in an if-else or switch case. So we enforce structure to outputs from the LLM. So you as a developer, when you call an LLM, you say, I want structure in this format, and we try to enforce the LLM to respond back with that structure. Here you can see, for an example, I defined a creature schema, which is a name, description, and size. And when I'm calling the model, I ask it to describe a fantastical creature that lives in habitat. and then I ask him to output in the schema, creature schema, and it responds to me with that. I can even put enums in there and ask it to choose between these enums and use that enum in like my code logic. It's as simple as that. And then evaluations are key. Evaluations is actually, during our research, we found out it's a bit difficult for developers, for app developers to grasp. So we try to make it as easy as possible. It's provided through plugins. We have a bunch of them pre-made, like RAGAS, like Vertex evals. But there's also support for like 3P evals that you can use in your application. And observability. So for observability, again, we didn't come up with a new standard. We just said open telemetry is there. App developers love it. A lot of the providers use it and support it. So let's integrate with that. So Genkit is built with open telemetry support at the core, and it directly integrates with all the monitoring platforms. You see that this screenshot is like in early days, we just implemented open telemetry support, ran a sample code, and we had everything available in Google Cloud Monitoring dashboard. So it's as easy. It was as easy as that, just getting support for all the major platforms out there. And then one of the key things that we have in the AI world is using notebooks. Notebooks are a great way for you to quickly iterate on your local machine and test out ideas. But the thing that happens usually is that you end up adding a lot of your logic in there, and then good luck taking that into production. Notebooks aren't production ready. So we thought, how can we recreate that experience for developers? We built a developer UI that can run in on their local machine in a browser. It would inspect their code, look for models that they've defined, look for prompts that they've defined, look for functions that they've defined that mix code and AI code together, and also their evals. And it brings them up, lists them up in the UI. You can start tinkering with those here. If you have models defined, you can play with the model. That's no big thing. But if you have prompts, you can tinker with your prompts and run them and see the results. You can directly see the traces of how that prompt went to the LLM, came back with like, exact timing, with like the trace ID, span ID. You can use these to go and see the tracing in your tracing tool, and with all the outputs and back and forth to the model. And you can run code directly there on your local machine with the AI code. So the mix of code and AI code, you get something from the generative AI model, you do an if then else on the result, you run another call, you come back, you call a database and come back. You can run all of these together in one call and get the trace results, get the feedback. You don't need to load your app and go and click that button or log in and like enter some text in the field. It can be run directly from your developer UI. And you can see all traces. And for evals, the same. You can see all the evals that you've run. You can see the scores that you got, and you can see the trace of each eval and how it resulted in that score. And then you have tools. You define tools as functions in your code. You can provide them to the model. The model, if it needs it, it asks Genkit to run it for them. There's an advantage to running the tools this way instead of actually the model calling into the tool, and that is like it keeps the security context of the caller. So if your caller runs with like a privileged account or like a restricted account, that same principle is applied to the tool call as well. And we have a bunch of optional utilities. We have lightweight abstractions to build production-ready RAG. We actually try not to build plugins and adapters for every data source out there or every component out there. So we embrace the developer to use the native SDK or the native interface. Like if you're reaching into Postgres, you build your own SQL query, or you're using an ORM, use your own ORM. Developers are using that across their application. We shouldn't like build something new and enforce something new for them. Just use the same pattern, and you can use that. We have lightweight components to help build agents. Because we're under Firebase, we built some goodies for Firebase developers, which they can hook Genkit directly into their Firebase stack. Like they can trigger Genkit directly from a write to their database. They can trigger Genkit from when a user gets added, like do something with the user, like send a custom email, or like when an HTTP request is made. All of those directly can trigger Genkit. But That's also like via a plugin, and it's open, and any platform can copy those, and they can build these integrations for their own platform. So nothing in the core of Genkit is coupled to Firebase and GCP. It's open source. As I said, it's open ecosystem, so people can build plugins. They publish on NPM, and it's available to others. We have no control over the plugins that are published. And as of 2 months ago, it was launched in TypeScript. As of today, we announced Go version as well in alpha. So now Go is also supported. And so finally, what's the takeaway here and what's the summarization? If we go back to the emerging LLM app stack that had orchestration, very bold, heavy, right in the center, coordinating between all the different components of your stack. Yeah, let's not do that. Let's not go after this way, but let's actually bring AI next to your business logic. Wherever your business logic is, your AI is part of your business logic, and let's actually embrace using AI next to your business logic. And we've built Genkit to support that. And these are Genkit's design principles as a summary. I've added them here. I won't go through them, but I covered them through our talk. And yep, that's it. Any questions?
What are the evaluation metrics that we're using Genkit?
So the ones we support out of the box are RAGAS and Vertex fast evaluations for now.
We also support local LLMs?
Yep. Okay. Yep. All of these are plugins. So it's just built in a way that anybody can, you can publish a plugin for your LLM and others can use it.
Thanks.
Other questions?
Any recommendations for how to track usage and cost across different LLMs, because the footprint for LLMs is growing?
Yeah, so you mean in Genkit, right? Or in general? Well, in Genkit...
I haven't found really anything, so
yeah.
Maybe Genkit would be great.
So in Genkit, we have a concept of middleware that you can invoke before calling to the LLM and after calling to the LLM. So basically what you do is based on the model cost method, whatever it is, like context size, token size, whatever, you can capture the prompt size, the context size, you can report it to your observability dashboard, and then you would track that on the other side, and you can set up alerts. If it goes beyond a certain point, you can alert someone, or you can start blocking more calls.
So I've used the LangChain, and maybe these examples weren't like the most convincing, but call me a skeptic, but I'm not convinced that Genkit is superior, like so much more superior than like just using LangChain as a developer, right? There's a lot of the complexity that Genkit hides is already hidden behind. If you want to go like all the way deep as you want to go, of course you can go use LangChain for in pretty much any language that you want. So I wanted to understand a little more of like what have you guys found in terms of like what kind of savings, like when you guys took it to developers, what did they say? Can we hear some of those stories, like some of those?
Yeah, sure. Sure. So LangChain is a great library, disclaimer. So I have like no comment about that. I think it's a different personas that we target than that. So we're looking for people, we're looking at people who are, their background is, I built a mobile app, right? Or I'm building something on cloud. I have this database and I use it to like load this into the pipeline, and I run queries on BigQuery or like on AWS and something, and I have these serverless functions that are running. So those types of complicated applications, and they already have an opinion about how to develop their app. About they put their business logic somewhere, they put their like infra logic somewhere, they use a CI/CD and so on. Genkit is more catering to them, right? So it hooks into their process, their mindset, their way of thinking. And LangChain, I believe, is for a different set where you can like quickly use the pre-built components, construct the chain, run it, get feedback, iterate on it, and so on, right? So the chain part is heavy in LangChain. And if you actually look at their articles, their blog posts, it's a lot about like those complicated patterns. What was the recent one I saw? It was something about graph lookup in RAG. Like this was one of the recent things I saw there. And they were referencing a 2012 Google article about like how Google search like builds a graph, a knowledge graph. So it's for a different mindset, but we specifically care about going to production. And the feedback we heard was that it's not as easy on the other side. And actually, we know a lot of products are being built to bring LangChain into like a production environment. But again, like great framework, like great concepts, great people there. One of the like you asked for feedback, so we did an EAP early access research between developers, and a lot of it was, oh my God, this is just so simple. I didn't have to learn anything. It was just like how I thought, and thank you for that. And they started with the basic model of, it's a function call. Then they thought about how am I going to observe this, and observability was there. They just needed to flip a switch, and observability was there. How am I going to test this? Here's evaluation, and here's how you can test it. So it's following that mental model, and that's how like developers like this and want to start using it.
Sorry for the tough question.
No, it's not. It wasn't a tough question. Like we've gotten 100 of these questions before we actually were allowed to build a new product. So don't worry. Yeah.
Did you find all the memes yourself? Did you use AI to help you find the memes?
I used the search like